Today we are going over corrections for Unit 6 test. Number 1 says Boris has a coin and a number cube. The number cube is labeled 1 through 6. So I'm going to write out 1 through 6. 1, 2, 3, 4, 5, 6. It says he also flips the coin once and rolls the number cube once. So the thing I haven't written down was the coin. So on a coin, you have heads and tails. So if he does both of those one time, there's going to be certain outcomes. So it's wanting to know what is the probability that the coin lands tails up. So tails up, and then the cube lands on an even number. So we have 2, 4, and 6. So when we go and find the probability of each one for the coin, 1 out of 2 times, because there's only 1 tails out of 2 total outcomes. And for the number cube, there's 1, 2, 3. 3 numbers out of 6 total numbers. Now we can reduce 3/6 down to 1/2 by dividing by 3. So now we have 1/2 and 1/2. When we have 2 probabilities, we multiply them together. So we have 1/2 times 1/2, which overall gives us 1/4 for the total probability, B. Number 2 says Tobias has 12 coins in his pocket. Of these coins, 8 were made in the year 2000 and 4 were made in the year 2005. So we have 8 in 2000 and 4 in 2005. And again, it told us there was 12 total coins. So it says Tobias randomly selects 1 coin from his pocket and without replacing it, so he keeps it out, selects another coin from his pocket. So what is the probability that both coins he selects were made in the year 2000? So again, it says he takes 1 coin from his pocket, and it needs to be the year 2000. So that would be 8 out of 12 total. Now it says he keeps that coin out. So instead of 12, we go down to 11 because we kept that coin. And we took 1 of these away of 2000, so now there's only 7. Because we drew that 2000 coin out and we kept it out. So now it wants the second coin to also be from the year 2000. So that would be 7 out of 11 total. And then we can multiply. Now, I like to reduce any fractions to the lowest possible form before I multiply because I like dealing with smaller numbers. So 8 over 12 could be simplified down to 4 over 6. And then if you want to keep going further, 2 over 3. So now we can multiply. We have 2 times 7 is 14. And 3 times 11 is 33. So our overall probability is 14 over 33, F. Number 3 says Leslie has 2 cups containing different colored paper clips. The first cup has 7 pink paper clips and 3 blue paper clips. The second cup contains 3 black paper clips and 1 red and 6 orange. So the first cup has 10 total, and the second cup has 10 total. So there's 2 different cups that we're looking at. It says, what is the probability that Leslie will randomly select a blue paperclip from the first cup? So let's figure that out first. So blue paperclip, we have 3 out of 10 total. So that's the probability for that. And then randomly select an orange paperclip from the second cup. So we have 6 orange out of 10 total. Now we do have to multiply them together, but I think we can reduce the bottom fraction first. So 6 over 10 if you divide both by 2, can get 3/5. Now that should make an easier multiplication problem. We have 3/10 multiplied by 3/5. So 3 times 3 is 9. 10 times 5 is 50. So we get 9/50, and D is our answer. Number 4 says a store manager receives a delivery of 2 boxes of light bulbs. Each box contains 25 light bulbs. The store manager tests all the light bulbs and finds that 2 of them are defective. Based on these results, what can the store manager predict about the next delivery of light bulbs? So in our story, we don't really need to know how much each box has based on the answers we have, because it's talking about the boxes and light bulbs. We don't need to know the total number. We just really need to know the number of the defective light bulbs. So out of those 2 boxes, 2 of them are defective. So that's an average of 1 per box. So we have to think, if we get 1 per box of defective light bulbs, we need to really keep that in mind. So each box should have 1. So F says a delivery of 3 boxes. It should have 3 defective light bulbs based on our theory. F says 3 boxes will contain 3 more defective light bulbs than a delivery of 2. So 3 more than a delivery of 2. That's very important because we're adding the 2 from right here. That would be 5 total. We said right here 3 boxes should be 3. So F is wrong. Let's look at G. A delivery of 4 boxes will contain 2 more. So remember, plus 2 from right here. That would be 4 total. We'll have 2 more defective light bulbs than the delivery of 2 boxes. Okay, so the boxes, again, had 2. So when we add 2 more, that would be 4 total. 4 boxes would have 4 defective light bulbs. That matches our theory of 1 per box. We know that 5 boxes should have 5. So 5 boxes should have 5. It says 10 right here, so that's not it. 6 boxes should have 6. This is 3 plus the 2 from up top will give us 5, so that is not the same number. So G is our answer. All right, so 5 says Mary bought 6 packets of tomato seeds. Each packet contained 24 seeds. She planted 1 packet of the seeds, 15 sprouted. So we know that 15 out of 24 sprouted for 1 packet. Now it wants to know what statement about the seeds in the remaining packets is best supported by this information. So let's figure out how many total seeds we're going to have. So to find out the total, we have 5 packets left because it does want the remaining packets. We already used 1 of the 6. So there's 5 packets left, and each packet has 24, so we're going to multiply that. 5 times 4 is 20, carry the 2. 5 times 2 is 10, plus 2 is 120. So there's 120 total seeds left. Now here we are going to make a proportion. So we have 15 over 24, because that's what sprouted from that first pack, equals X over 120. 120 is our total, just like 24 total seeds in a pack. We want to know how many sprout. Well, in our first pack, 15 sprouted, so that's why it's next to the X. So we're going to cross multiply here. 120 times 15. Get 0, 10, carry the 1, 5, 6. Done with the first number. X for place value. 1 times 0 is 0. 1 times 2 is 2. 1 times 1 is 1. Now we add it up. We get 1,800. Now we divide down. So we go top in, bottom out. 24 goes into 1 0 times, into 18 0 times, into 180. I'm not 100%, so let's multiply. I know 20 times 7 is 140. 20 times 8 is 160. So let's try 8. 24 times 8. You get 32, carry the 3. Get 16, 17, 18, 19. So that's too high. So let's try 7. Get 28, carry the 2. 14, 15, 16, 168. So there's 7. Gets 168. Subtract. Have to borrow. We end up getting 12. Bring down the 0. Now, we know there's going to be another number here. Okay, where the x is, there's going to be another number. Now, with that being said, it's somewhat in the 70s, right? Somewhere in the 70s. So for our answer, A says no more than 50 seeds. Well, 70 is more than 50, so that's wrong. Between 50 and 100, that seems like the right category. C says at least 100. Well, 70 is less than 100, and then 70 is also not 120. So our answer is B, and you didn't have to finish all the work, but you did have to do quite a bit of work for this problem. Number 6 says, in an experiment, a fair-sided number cube numbered 1 through 6 was rolled 2 times to determine the probability of rolling an even number in the first roll and a number greater than 4 in the second roll. The trial was repeated 10 times. The sample space and the data from the experiment are shown below. What's the experimental probability of rolling an even number? So an even number on the first roll, so let's go and circle those. So we got even numbers on the first row circled. And then a number greater than 4 in the second roll. So 5 is greater than 4, and 5 is greater than 4, and that's it. Okay, so out of these, there's only one right here that has both rows circled. So we have 1 total that has both circled out of 10 total. So that is your answer, 1 out of 10. Number 7 says Jessica is conducting an experiment using 2 bowls of marbles. She reaches into each bowl, draws a marble, records the result, and then returns it to its bowl. She repeats this experiment for each bowl 20 times. Her results are shown in the tables below. Based on these results, predict the number of times Jessica will draw a purple marble from bowl 1. So let's figure that out. Purple is right here. We know there's a total of 20 because it told us. So we can write 20 total. So the probability would be 4 out of 20 for the first bowl. And then it says a white marble from bowl 2. So white marble is here. That's 6. So there's 20 total. Sorry, cannot spell. 20 total. So that would be 6 out of 20. Now we can reduce both of these. 2 out of 10 and 1 out of 5. When we reduce down, 6 over 20. We divide by 2, get 3 over 10, and that's where we have to stop for that one. Now we have to multiply those together. So we have 1/5 times by 3/10 to get 3 over 50. So now we can set up our proportion. So we have 3 over 50 equals x over 200 because it wants to know for 200 total times. So we cross multiply. 200 times 3 is 600. Divide down by 50. Top in, bottom out. 50 goes into 6, 0 times into 60 once. That is 50. Subtract to get 10. Bring down the 0. 50 goes into 100 twice. So we get 12 as our answer, which is B. Number 8 says, Bobby had a box of berry-flavored hard candies. 15 were strawberry-flavored, 12 were blueberry-flavored, 13 were raspberry-flavored. Bobby picked one candy from the box without looking. What's the probability written as a percent that the candy he picked was not raspberry-flavored? So first we got to figure out how many total flavors or total candies we have. So we have 15 strawberry, 12 blueberry. Let's add those together. Get 27. And then we have 13 raspberry. So we have 40 total candies. Okay, now it's the probability that he did not pick a raspberry. So it said raspberry was 13. Okay, so we need to take everything but raspberry, and that's going to be our top number. So when we added 15 and 12 right here, that's strawberry and blueberry. So we already know this is the number we are using. 27 over 40, because 27 were not raspberry over 40 total, is our probability. Now we need to turn it into a percent. When we have a fraction and we want to turn it into a percent, we have to divide first, so top in, bottom out. Okay, so 40 goes into 2 0 times, into 27 0 times. So we have to add a decimal and a 0, add a decimal up top. 40 goes into 270. I believe it's going to be 6 times. But let's multiply and make sure. 0, 24. Okay, let's try 7 just to make sure. 0, 28. So yep, it'll be 6 times. So that is 240. Subtract, we get 30. Add a 0, bring it down. 40 goes into 300. 7 times, that's that 280. We just figured out. Left with 20. Bring down. 40 goes into 200, I believe 5 times. Get 200, so it is 5. So we get 0.675. So now what we have to do is move it over 2 decimal places, because when we are going to percent, we have to add 2 decimal places to it. So we get 67.5. F. Number 9 says Mike has a stack of 10 cards numbered 1 to 10. He randomly chooses 2 cards without replacing. Remember, we corrected that during the test. Replacing the first card drawn. What's the probability that Mike would pick 2 cards that are prime numbers? So Mike has a stack of 10 cards. So 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Chooses 2 cards without replacing the first card drawn. What's the probability that he picks 2 cards that are prime numbers? So first we got to know what a prime number is. So prime numbers, 2, 3, 5, and 7. So the definition of a prime number is a natural number greater than 1 that is not a product of 2 smaller natural numbers. Okay, so 2 can't be multiplied by anything to get 2. 3 can't be multiplied by anything to get 3 other than 1. 4 you can get 2 times 2. 5 you can't do anything. 6 you can get 3 times 2. 7 you can't multiply anything to get 7. 8 you can do 2 times 4. 9 you can do 3 times 3. 10 you can do 2 times 5. Okay, so that's how we got 2, 3, 5, and 7 as our prime numbers. So the probability of him drawing a prime number to start off would be 1, 2, 3, 4 out of 10, which we can reduce down to 2/5. Okay, we took 1 away, so let's say we take the 7 away. Now we have 3 prime numbers out of 9 numbers left. Okay, we can reduce 3 over 9 to 1/3. Then we can multiply to get 2/15, which is A. Number 10 says Bethany's middle school has 850 students. She randomly selected a group of 45 students from her middle school and asked them their favorite hobby. She recorded their responses in the table below. So she already told us that there's 45 students participating here, so we don't have to add it up. Based on these results, which inference can be made about the number of students at her school who would name jogging as their favorite hobby? Okay, so when we look at it, we know jogging is the highest, then reading, then playing sports, then drawing, then origami. So let's look at our answer choice to see which one best fits. Bethany concluded that more than 300 students chose jogging as a hobby because it is more fun than reading. Okay, so when you're making an inference, you can't use any descriptive words or, not descriptive words, can't use any opinionated words. So more fun could not be the reason they chose it. So since they said more fun, that cannot be an answer because that is an opinionated answer. Okay. G says Bethany concluded that it is more likely a student in the school will like either reading or playing sports than they will like jogging. Okay, so to figure that out, we have to take reading and playing sports, which is 18. So we have 18 for reading plus sports. Then we have 18 for jogging. Since they're the same, it would not be more likely that a student would do either. So G cannot be our answer because they are the same. H says Bethany concluded that 340 students at her middle school would prefer jogging as a hobby. So to figure that out, we take jogging, which is 18, over the total, 45, and we make our proportion, x over 340 total, 850. We have to remember up here it says there's 850 total. Okay, H is thinking that this x should be 340. If it is, then H is true. So to find our x, we cross multiply. 850 times 18. 40, carry the 4. 64 plus 4 is 68. Get x for place value. 1 times 0 is 0. 1 times 5 is 5. 1 times 8 is 8. We add it up. Get 13. Carry the 1. 15. Now we have to divide by 45 because we divide down. So now we have 115,300 divided by 45. 45 goes into 1 0 times, into 15 0 times, and 153 I'm going to say 3 times. So let's try it out. Get 15, carry the 1, 12, 13. Yep, because we can't go anymore. So 3 times. Get 135, subtract. We have to borrow. So 13 minus 5 is 8. 4 minus 3 is 1. Bring down the 0. Okay, let's try 45 times 4. Get 20, carry the 2. 16, 17, 18. Get 180 exactly, so this is 4. Get 0, bring down this 0. 45 goes into 0, 0 times. So x is 340 based on our calculation, so H is your answer. Number 11 says Chad plans to spin the spinner below 40 times. Which equation can be used to predict how many times the spinner will land on 3? So we have 1, 2, 3, 4, 5, 6, 7, 8 total spots on the spinner. 1, 2 of them are 3. Okay, so we have 2 out of 8 that are landed on the 3. So we look down there and we figure out how many of our answers have 2 out of 8 as an answer choice. So we can take away C and A, because 2 out of 8 here, 2 out of 8 there. Now, it wants to know out of 40 times, okay? So when we make our proportion, we have to put, just like both of our answer choices say, x over 40. Okay, now we cross multiply. 40 times 2 is 80. Then we divide down. 80 divided by 8 is 10. So our answer choice B would match up because it has 10 as the answer. D has 20 as the answer right here, so that cannot be it. So B is your answer. Number 12 says, which diagram best represents all possible outcomes of rolling a number cube numbered 1 through 6 one time? So I throw that number cube once, and I should get 6 different outcomes if I were to do that, or I have 6 total outcomes possible. Okay, so for F, that looks like it's my answer because I have 6 different outcomes from one event right here. Okay, H has one event here, and it only shows me 2 possible outcomes. So H can't be it because I have 6 total outcomes possible. Okay, J has 1 outcome, but only 4 results. So that can't be it because we have to have 6 total possible outcomes out of one event. G, 1 event, we only have 3 outcomes. Should be 6, so G cannot be it either. Our answer is F. Number 13 says, Jonathan rolls a fair 6-sided number cube, numbered 1 through 6, records the results. Which statement about this experiment is true? He is more likely to roll an even number than a multiple of 3. Okay, so let's think about that. There's 3 even numbers out of 6, and the multiples of 3, there's only 2 out of 6. Okay, so the even number is more likely than a multiple of 3, so A seems like a pretty good answer. But let's check the others. B says he's more likely to roll a composite number than a prime number. So a composite number is a positive integer that can be formed by multiplying 2 smaller positive integers. So for a number cube, that would only be 4 and 6. Okay. And then the prime numbers we learned earlier, that would be 2, 3, 5, and that's it for a number cube. Okay, so composite number would be 4 and 6. That's 2 out of 6 total. The prime numbers are 2, 3, and 5, so that's 3 out of 6. So that's not correct because composite's less than the prime. C says he's more likely to roll a 6 than an even number. So there's only 1 6 out of total 6 outcomes. An even number, there's 3 out of 6. So C can be wrong. D says he's more likely to roll an even number than an odd number. Well, there's 3 out of 6 even, there's 3 out of 6 odd, so they're not more likely. It is the exact same probability, so D is wrong. So A is our answer. 14 says Patrick and Shelby are playing a game. They toss a fair 6-sided number cube, numbered 1 through 6, and they spin a spinner which is divided into 2 equal regions, 1 colored red and 1 colored blue. Which list shows all possible outcomes of spinning the spinner and tossing the number cube? So for a number cube, there's 6 total possible things, and they want to know all the outcomes. So we know there's 6 different outcomes for the number cube, and then there's 2 for the spinner. To figure out the total number of outcomes possible, we have to multiply these together. The 6 total possible outcomes times the 2 total possible outcomes to get 12. So that's going to be, there's 12 different outcomes that could be possible from these groups. Okay, so let's count up how many outcomes each answer choice has. 1, 2, 3, 4, 5, 6. 6 is not 12, so F is wrong. Here we have 1, 2. 2 is not 12, so G is wrong. Here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is 12, so H should be our answer. Next one, we got 1, 2, 3, 4, 5, 6. 6 is not 12, so J cannot be it. So H is our answer. 15 says Ricky rolls a fair six-sided number cube, numbered 1 through 6, 18 times. How many times should Ricky expect to roll a number greater than 4? So, on a number cube, 1, 2, 3, 4, 5, and 6 are numbers. Numbers greater than 4 are 5 and 6. So that is 2 out of 6 possible numbers chosen. But he wants to do it 18 times. So we have to do our proportion, x over 18, because 18 is the total number. We cross multiply to get 36, then divide down by 6. 36 divided by 6 is 6. So it would be B. Number 16 says Brandy wants to participate in an after-school program. She has a choice of 1 art class. So there's 1 art, 3 dance, 2 gymnastics. I'm just going to put gym. Or 3 sports. She cannot decide, so she writes the name of each class on a slip of paper and draws 1 slip out of the bag. What is the probability that she does not choose a dance class? So let's add all these up first. So we got 4, 5, 6, 7, 8, 9. 9 total. So 9 total. Okay, and it says not draw a dance. So we have to figure out not dance. So if there's 9 total, 3 of those are dance. We take away 3 to get 6 that are not dance over 9 total. So now when we reduce this number, we can divide each by 3 to get 2 over 3. So your answer is J. 17 says a collection of marbles is shown. What's the probability written as a fraction of selecting 1 green marble from this collection? So we have to count up how many total there are first. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So we have 18 total. Now we need to figure out the green marbles. We have 1, 2, 3, 4, 5, 6. Okay, so 6 green. There's our fraction right there. Now we have to reduce. We can divide each by 3. So 6 divided by 3 is 2. 18 divided by 3 is 6. We can go again. So that would be 2, divide by 2 to get 1/3, B. 18 says Silvio created a table of the possible outcomes of spinning a spinner divided into 4 equal sections labeled A, B, C, and D, and rolling a fair 6-sided number cube numbered 1 through 6. A sample space of the results is shown below. Using the sample space, what's the probability of spinning the letter A? So that is this column right here. And rolling a number less than 4. So less than 4 is here. Sorry, not the 4. We have less than 4. That's 3, 2, and 1. Okay, so the only one that has both of those are these 3 right here in the green. All right, so now we need to make some probabilities. So that is 3 out of, let's see how many outcomes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, 24. We can reduce that. We can divide both by 3. 3 goes into 3 once. 24 divided by 3 is 8. So we get 1/8 as our answer, H. 19 says Josephina lives on a farm with 3 sheep, 2 goats, 11 chickens, 5 cows. So let's add that up. 3 plus 2 is 5, plus 11 is 16, plus 5 is 21. She is going to randomly select an animal to take to the stock show. What's the probability she randomly selects a cow or a goat? So goats 2, cows 5. Together that is 7 total animals. So we have the probability 7 out of 21. Now when we reduce, we can divide by 7 to get 1/3. A. And number 20, a spinner is divided into equal sections that are labeled with integer values. What's the probability of the arrow not, super important word, not, landing on a section labeled with a positive number if the spinner is spun 1 time? So we want the arrow not landing on the positive. Okay, so we want the arrow landing in here on the negatives. So that is 2 out of 6 total. When we divide, we get 1/3. So H.